Alright, so now we're going to talk about radical expressions, and we're just going to start with the tip of the iceberg on those. We're going to start with the nice ones that clean up nice and neat and get familiar with the way they're connected with our rational exponents. Okay, we back here talked about writing the nth root of b as b to the 1 over n power. Another way we can write the nth root of b is using a radical. So if I want to write the fifth root of 32, maybe I could slide all of these over at once. Instead of writing 32 to the 1/5 power, I can use a radical to say the fifth root of 32. Maybe I want the fourth root of 81. This is a 4, can't really tell. So I put a 4 there in the radical. I can't get my tablet to line up with my computer screen. If I am talking about a square root, the square root of 49, okay, I can leave the number out of that little dip completely, out of that little v. If nothing's written there, it's understood to be a 2. Okay. But if it's any other root other than a 2, I have to put what root I'm talking about there. So when we see a radical, we need to be able to make the connection between it and it using rational exponents to ask for the same thing. Because there are times when it's going to be presented in one way, and we need to make the connection that it's the other. So if I see on my paper this expression, this is asking me for the square root of 25, and the number that I square to get 25 is 5. In words, this expression is asking me to find the cube root of 8, or what number times itself 3 times is equal to 8, and that number is 2. The nice thing about this first section on radicals is that all of the radicals clean up nicely. You're going to get integer values out of all of them. Okay, think about, I like 64 because there's a lot of possibilities here. 64 has a sixth root, it has a cube root, it has a square root. Okay, so here in a moment, pause the video and see if you could determine what times itself 6 times is 64, or what times itself 3 times is 64, or what times itself is 64. And then turn it back on when you want to make sure that you're right. So 2 to the 6th is 64, 4 cubed is 64, 8 squared is 64. So that's what we have. Now, if the cube root of -8 is what we're asked to find, then we have to think what times itself 3 times is -8. And since 2 cubed is +8, if I take -2 times itself 3 times, notice I get -8. But maybe I'm asked to find the square root of -25. I know that 5 times 5 is 25. But if I try to come up with a number that I take times itself to get -25, I'm not going to be able to come up with one. Because no real number squared is ever going to be negative. Some of you know how we're going to define this later on, but for those of you who don't, even if you do, all we're going to do in this section right initially is say, well, that's not a real number. So I can't square a real number and get something negative, but I can cube a negative number and get a negative. Okay. The fourth root of 16, if I break 16 down, I find out is 2. But if I want to find the fourth root of -16, I run into the same problem as I did with the -25. Any real number raised to the 4th power is going to be a positive number. So I say, this is not a real number. Okay, and then I stop right there. Okay, it's not a real number. We don't say anything more than not a real number. Okay, undefined is wrong. No solution is wrong. It's not a real number. And so that's how we describe it. If our root is an even number, so square root, or fourth root, or sixth root, or eighth root, okay, then I cannot take an even root of a negative number and get a real number for an answer. If the root is an odd number, 3, 5, 7, 9, okay, then I can take an odd root of a negative number. My answer is just going to be negative. Okay. Also, there are a few fractions and things scattered throughout this section. And the nice thing is, if you're asked to find the square root or the cube root or the fourth root of a fraction, it's the way you would want it to be. Meaning, take the square root of the top and take the square root of the bottom, and then make sure your answer is in lowest terms. If it's not, then reduce it. Okay. So our initial situation with radicals, they're all going to be nice. We'll have integer or nice rational values, or occasionally we'll say that's not a real number. Okay, but everything cleans up and the radical goes away the first time we see this.